Cheyenne, how many terms are there?
4.
There's 4. What are the like terms? Which ones would you pair up? Allison?
There's the negative 2, there's n, and 7n.
Okay, those are a pair because remember n, they both have n to the first power in them, so they both are like terms. Is there any other like terms in there? Sam?
Negative r.
Uh-huh.
Negative r and 10r.
Mm-hmm. Now, you just told me how many terms there were. You told me what terms were alike. Okay. Now, could you simplify this if I asked you to simplify it? How would you simplify it? Right now we start with 4 terms. What does simplify mean? Seamus? Yeah, put things together. Now put the like terms together. What would be the new n term if I put those two? If I put these 2 terms together, what would be my new n term? Ronnie?
5n.
5n. And if I put these 2 r terms together, what's our new r term? Okay, you paying attention?
Yeah.
What would be the new r term?
10r. If you put 10r and 5n together?
No, 10r and negative r.
It would be negative 10r.
Nope. Miss Kidd?
9r.
Mm-hmm. So then obviously you're going to attach, remember how you have to have an operation here between the 2 terms to separate the 2 terms. So this is our new expression. Okay? This is our beginning expression, but if we simplify it, it becomes 5n plus 9r. Okay? So I can ask you how many terms an expression has. I can tell you, or ask you to find the like terms, if there are any. They don't have to be. And then, if there are like terms, could you simplify it? Those 3 skills right there should be something that you should be already be able to do. You've been doing it. You did it on your last test. Okay, so it's just reviewing what we've done. All right, so if you would, get out your homework. And I will collect it. I'm going to fold this. Okay. And then I'd like you guys to get out your notes and look at the first problem and ask yourself, what would I do with this situation? Okay, thank you. Just hold it. Do I have yours?
I get it.
Copy? Okay. Jenna, you got yours? Thank you. Scott, can you get the lights on? Okay. All right, first off, in this situation right here, could you guys box the variable term? You're on the first slide where it says combine like terms and equations. Please box the variable term right now. Should be on the note sheet. What do you notice? There we go. There, and I got the space. Ronnie, what do you notice?
There's 2 x's.
Ooh! So right now, we have 2 x's. On the same side. You guys agree that they're all on the same side. They're on the left-hand side.
Mm-hmm.
Do you want to know a little secret? When this situation happens, guys, one thing I want to tell you is, you guys agree that this is the left-hand side, there's the right-hand side. Before you can create the zero pair, which is our first step, right? Normally with two-step equations, like last night's homework. Didn't you create the zero pair first? Then you got rid of multiplication, division, or fraction, correct? Before you can do any of that, ready? This is the most complicated a psi can be. Okay? You can have one variable and one constant. Okay? On the left side and the right side. That's the most complicated it can be. So look at the right-hand side. Is the right-hand side okay? Okay? I'm saying the most you can have on a side is one variable term and one constant. You can have less than that, but you can't have any more than that. So what's the problem over here? Because I don't believe I have a 1-to-1 ratio, do I? What's the problem? Because I only can have one variable term and one constant on a side. Seamus?
You have two of both.
You have two of both. So what do you think we're going to have to do? Think about what you just did on the bell work today. Samantha?
Combine
Didn't we just do that on our bell work?
the
Hey, a little quinky-dinky, huh? A little coincidence. So, what would these two x terms turn into? What would be our variable term? Cheyenne?
2x.
All right, let's write it down. There you go. Right underneath. Now, what else can we put together? Can we put the constants together? Joe, what does a 1 and a -5 make? -4. Now, don't forget the negative is on the 20. Now, look at the sides. Look at our left-hand side. Now, are we okay? Do we have one variable term and one constant? That's the most we can have. We can have less than that, but we cannot have any more than that. We have at least one of each. Now we can do whatever we did yesterday. Okay? Because now, when we box a variable term, don't we just have one box? And then aren't we back to where we were yesterday? So, what's our step? What do we create first? Ronnie?
+4.
What do we create? If you put a +4 with -4, what are you creating?
0.
Zero pair. There you go. So we're going to create our zero pair first. Bring our equal sign down. This cancels this. So what's the only term left now? We got rid of the -4. What's the only term left, Anthony?
2x.
2x. Nice. What's our new constant on the right-hand side? When we put those two terms together, what's our new constant, Chris?
-16.
What's our final step? What's our last step there? Mariana?
To divide.
By what, honey? Because remember, these need to be 1, and 2 divided by 2 is 1. And what does our x equal, guys? Gates? -8. It's our final step. Now, these are a little more intense. This is the rule. Listen to me. When you check these, where do you plug x in? Do you plug it in here or back to the original? What does your instinct tell you? Think of what you've been doing. Let's see if somebody can put 2 and 2 together here. Joe? Why do you suppose I don't go the 2x minus 4 equals -20? Why do you think I tell you not to do that? This kid?
Because it was simplified.
It is simplified. You never go with the simplified. Because obviously you did that. You calculated that, correct? Anthony?
Because it's not the first step.
No. Think about it. If you plugged in x right here, and it checks out, you're like, woo, but then you get it wrong. Think. Gates? What if you simplified wrong? What if you made this negative 2x versus positive 2x? You see where, is that right? No. But when you solved it from here, you got a positive 8 versus a negative 8. Do you see my problem here? You never use this. Because if you simplify, what if you simplified negative 4 wrong? You made positive 4. You see? That, because if you simplified it, you did the calculation, didn't you not, to get to this row right here? Didn't you calculate to get to there? You can't use that.
So you made a mistake.
Have you ever made a mistake on an equation? I think you're all guilty. None of you are perfect. Okay? So, when we do these, okay, when I have you do these, now obviously these are more, the checks are a little more, there's a little more work that goes along with it. Okay? So, let's go back to, I'm going to erase this section right here. I'll show you how this works. So we're going to go left to right. We're going to start off with 9 times our x plus 1 minus 7 x's. Oops, we have to put x in there. We don't have x, we need to check it. So we're going to put x right here minus 5, and that has to equal, what, negative 20. And I'll write that down in a second. Now, what does x equal? Negative 8. And if you notice, doesn't it look like a GEMS problem?
Mm-hmm.
Just more operations involved. Okay? So, left to right, what do we do first? Yeah.
Multiplication.
Multiplication. So we got 9 times negative 8. What's that?
72 negative.
Negative 72 plus 1 minus 7 times negative 8 has to stay negative 5, or minus 5 has to equal negative 20. So next, we have addition, or what's this operation here? Multiplication. What do you do next now? Okay, what's a negative 7 times a negative 8? Positive 56. So I'm going to add 56. That's negative 20 there. So I'm going to bring my 1 down and my negative 70. Woo! There you go. All right. Now, what all do we have left? We have positive, which is addition, addition, subtraction. So don't we just have positive, negative numbers left?
Mm-hmm.
Everybody remember what we can do from here? Do we have to go left or right?
No. Oh, yes.
No, we don't. Why? Because what can you think of these numbers as?
They're, oh.
Remember your color day? Remember your red and blue? What do we do with reds and blue? Remember when we had our color pencils out? Samantha? Yeah, group them. So, group them. So, we have negative 72 and a negative 5. How many negatives we got? What's negative 72 and a negative 5? Put 5 more negatives with it. What do you got? Miss Kidd?
77.
Okay, so we have negative 77. What about a positive 1 and a positive 56? How many positives do we got? How many positives we got, Ronnie?
Positive 57.
Now, look at those. Look at those two. What's the difference between 77 and 57? Jenna?
77 is negative and 57 is positive.
So what's our answer going to be? And what's the difference between 77 and 57? So it's negative 20 is equal to negative 20. And that checks out. Questions on that one? Joe, turn around.
Nay.
Ooh, got nothing.
I like that problem. Pretty easy.
Try that one.
Oh.
You must have an extra slide in there.
Oh, you must.
Let's try this one. So what are you going to do? What do you think we're going to need to do? Remember, the most complicated side, a left side or a right side of an equation. What can what kind of terms? What's the most number of terms can we have, and what type on each side? What's the rule? What did I just say? What's the most you can have on each side? Allie? And what type of terms can you have? How many variable terms can you have on a side? I want to know how many variable terms can you have on a side before you can do, you know, addition, subtraction, multiply, or divide. 1. How many constants can you have on a side? 1. What's wrong with the left-hand side? What's wrong with it, Alyssa? The left-hand side.
There's two variables.
Yeah. Can you have 2 variables?
No.
No. So what are you going to do with these 2 terms?
Simple.
Yeah, how many x's do we have? We put them together. So these 2 terms turns into 8x. What operation is that? Sam?
Multiplication.
Yeah, how do you get rid of multiply? Jenna? Yeah. What are we going to divide by?
8.
Yeah. And what does our x equal? You and Tony? There you go. Now we're going to check this, and we're going to go left to right. You're going to just rewrite it, and everywhere you see an x, you're going to put a parentheses. That has to equal negative 64. Okay? So this right here is going to be negative 8. This is going to be negative 8. So, starting left to right, what's negative 5 times negative 8? 40. And now we have 40 plus 13 times negative 8. So what's 13 times negative 8? Chris?
Negative 104.
Negative 104? Now, we're going to take 40, subtract 104, or put 40 and a negative 104 with it. First of all, which one has the largest absolute value? Joe? So what's our sign going to be? Negative. And obviously, what's the difference, Ronnie, of those 2 absolute values?
Negative 64.
Negative 64. So we got negative 64 is equal to negative 64, and it checks out. Woo! All right? So, the first thing that you have to identify in the problems now that you're going to see on your homework, you're going to see from today on, that you're going to see problems that are going to have more than one x term on a side, or more than one constant on a side. The rule of thumb is before you can start dividing or creating the 0 pair, stop, make sure both sides have no more than one variable term and one constant. Otherwise, you can't do a thing. You're stuck. You got to simplify both sides, all right, so that there's no like terms on either side. That's basically how I remembered it when I was, you know, a student. I always remembered, look at both sides. You need to combine any like terms that you can, just like we did in our POD, all right? And then, now you can start getting rid of, okay, 0 pair, getting rid of addition or multiplication, division, or the fractions, all right? So you can handle that? Pretty good? Okay, everyone good? We have one other type, and then this is the last type of equation I'm going to expose you to. You ready? You guys already take a gander at it? All right, have you seen it before?
Yeah.
Have you ever seen this? Have you ever used this property? You remember how to use it? You remember what operation is when you have a number next to a parentheses? Joe? Now, do you guys agree that if you look at this situation right here, x is stuck inside the parentheses? Can you do anything with x where it is? Remember I told you about distributive property? You're kind of like stuck, aren't you? You really can't do anything right now, can you? Unless you do what?
Multiply.
Distribute the 4. Okay? So, what you're going to do, if you notice, okay, remember we did, we're going to take this number right here, whatever number's on the outside, and take it and multiply it by each term inside. So if I take a 4 times an x, what's our new term? Anthony?
4x.
4x. If you distribute a 4 to 5, or distribute a factor of 4 to 5, what is our new term? What's our new constant? What's 4 times 5? 20. Are you going to distribute the 4 to the negative 8? No, that's not even on that side. That equal sign kind of, this side stays over here, this side stays over there. Okay? Voila. Could you do it from here?
Mm-hmm.
Do you know how to do it from here?
Yes.
What would you do first? First of all, are each of the sides simplified? Does each side have at least one variable term and one constant?
Yes.
If you say yes, then you can start with the 0 pair, okay? I'm not going to have you guys do this. I just want to do practice. Because seriously, can you not solve it from here? Sure you can. You see what I'm saying? Let's not waste time. I'm going to go do another one. Is that cool? We'll go to another one. Let's practice. Let's do this one. I want you just to distribute it, okay? So I want you to rewrite this equation without the parentheses, which means distribute that. What are we distributing? 36 or 6? 6. This is what you're distributing. I want you to rewrite the equation, getting rid of the parentheses, using the distributive property. There you go. Good. I think it matches mine now. Why are you left to right? Everyone good? Could you solve it if I asked you to solve it right now?
Yep.
You sure could. All right, one more. Dace, you have a question, honey?
How would you do the check?
How would I do? I'm going to do one with you. Okay? But I'm saying let's do one of the harder ones. Okay? Once you solve it, you want me to show you? I can show you.
Oh, yeah.
Gates asked, how do you check this, Alms? Well, let me just show you. We got 66 is equal to what? Now what are we going to do next? What would you do? You guys agree with Gage? We're going to divide here?
Mm-hmm.
If you tried it, I know that some of you did, so hopefully you divided. And my x is equal to 11, right? We always use this form. So watch. Ready? We're going to rewrite this. 36 is equal to 6 times, here's your x, right? So x is 11 minus 5. Okay? So look at this. If I cover this up, what would you do first? What's our gens say? What do we simplify first? The parentheses. Well, so it's 11 minus 5. What's 11 minus 5? 6. So now you have 36 is equal to 6 times 6. Is 6 times 6 equal to 36?
Yes.
Sure it is. That's how you do that. So you'd have parentheses, which means you have to use the gens. Simplify your parentheses inside. But be careful because sometimes this x has a 2 in front of it. So now you have 2x. Do you see how I put it in parentheses still? You're still going to need to put it in parentheses just in case you have a coefficient on that x term. Okay? All right. Let's do another one. Oh, here's one. Right here. This is why I wanted to do this whole one with you. Is that cool? Because the other two, I think, once we distributed, once you got the, you could, that'd be like one you had in your homework lesson. You could just go. All right? So let's do this one. Let's distribute. Okay? What are we distributing? 2. It tells you right here. Can't read. All right, so 2 times 2x is? 4x's. And 2 times negative 5 is? Negative 10. Are we going to distribute the 2 to a positive 4?
No.
No. Why? Why don't we distribute the 2 to a positive 4? Why do we not do that? Miss Miller?
Because the 4 is not in the parentheses.
If this parentheses was way over here, sure. Now I see how we distribute it to all 3. But the parentheses stops right here. So these are the only 2 lucky terms. Okay? They're the lucky ones. They get another factor of 2 multiplied. All right. So now we're going to bring this straight down. So we're going to bring positive 4 down is equal to 9. Can we create the 0 pair?
No.
Why did she even say no? What's wrong with the situation here? What is Anthony?
There's 2 constants on one side.
Can't have it. Remember, 1 to 1. I always say 1 to 1 ratio. You can't have more than one type of term on the side. Otherwise, you're going to cause a lot of havoc. You're just going to cause a lot more problems. So when you put the two constants together, Anthony, what are you going to have? We have 4x. Is 4x going to change? We don't have another x term. So how do you, when you bring these two together, what do you get? What's our new constant?
6, -6.
Negative 6.
6.
Now, do you guys agree? From here, isn't it a two-step? Now can we create the zero pair? Can we start? Now we can start. Okay? We have one of these and one of these. We're good. Okay? We're good? Let's go through this whole one. You do it, I do it, and then we'll come back and we're going to practice the check. Okay? Now you're going to notice the next couple of assignments, I'm not going to make you check all of them. Now you can check them all because some of these checks are a lot longer, aren't they? Can you check them all? Absolutely. But I want to make sure that you practice. I'll give you a couple. Hey, these are the problems I'm expecting you to check. Okay? You can check them all, which I think is a good habit. Okay? Let me tell you. When you come into class knowing that all of your checks check out, you feel good coming into class. Okay? When your checks don't work out, you know immediately that you did something wrong. I didn't have to tell you did something wrong. You know. You figured it out on your own. And I think as a teenager, I'd rather figure that out on my own than an adult telling me what to do. I don't know. It's just my thoughts. Okay? Because you guys got to start thinking for yourselves. Okay? Mom and Dad are not going to sit here and direct traffic your whole life. Okay? So this is the time where you start, okay, is this the case or not? Making that thought process on your own. It's good. Okay? It's like called young adult thinking, Start thinking for yourself. All right. So I'm going to, Ms. Kaufman.
Yes.
How are ya?
I'm good. How are you?
Oh, good. What the heck did I do?
Yeah, that's what I was thinking.
Yeah, I was doing that.
That's
Thinking,
what I was
wait.
15.
Yeah, what? Did I type this wrong?
15. Did it
Very
wrong.
nice.
All right, hang on. Hold the phone.
I don't have your phone on me right now.
15. Let's do this. Let's make this
Lettuce.
10.
Lettuce.
Let's make this 10 and make this 16. How about that?
Lettuce.
That's what I was thinking, but I wasn't sure.
We can do
See,
it.
I can manipulate numbers to make them work. I was going to become an accountant.
I thought you were gonna try. I thought you were trying to do the decimal thing.
No. Not yet, Ronnie. I'm not going to do that to you. What does our x equal then, guys? 4, yeah. All right, so now let's plug this in. We got 2 times 2 times 4 minus 5 plus 4 has to equal 10, okay, since we changed that. Now, again, we're going to simplify the parentheses. How about this? Let's combine some steps. Let's simplify this all into 1. Can you do this in your head? Can you multiply by 4 and 2 times 4, and then subtract 5? Can you do that? What do you get? 3. So let's do that. Couldn't you do that in your head? Make it a lot easier? Let's see. What's 2 times 3?
6.
6 plus 4, 10?
Yep.
That checks out. Okay, does that make sense now for the check?
Mm-hmm.
Okay. You see, all it does is it turns into a gem problem with parentheses. Which you've done tons of those. Right? Since the beginning of the year, you've done lots of those little puppies. Any questions? Want to try some on your own, or are you guys ready for your homework, or you want to do another one? One more? Homework! So you guys can do that? You can distribute that?
Yeah.
We're good?
Yep.
And the last one, I think.
Yeah, we need to do fractional.
Huh?
Fraction.
I was going to do that tomorrow.
Oh, okay.
Let's not get our panties in a rumple.
I don't.
I don't have any.
What? You said
You're not wearing...
I'm
Ronnie,
No, I'm
Ronnie.
not having panty. I don't have. I'm
No.
not wearing panties.
Now, what I was going to do is, Mrs. Kaufman, do you think this is a good way? We will start with this problem here tomorrow, and we'll include that problem with these.
Oh.
Is that good?
Yeah.
So we stop here. We'll do the the opposite sign on the outside, and then fraction, since those are a little bit different. Even though there's still, you guys still see distributive property, right? And I'm going to show you how to distribute a fraction. Do you all know how to multiply?
Yes.
Do you know how to divide?
Yeah.
Isn't that what a fraction is?
Yeah.
So you know how to multiply by 2?
Yeah.
Divide by 3?
Yeah.
That's 2/3. See, if teachers would, obviously when you were younger, you weren't maybe able to think that way. But if you know how to multiply by 2 and divide by 3, you can distribute 2/3 in your head.
It'd be 4x minus 6.
I'm gonna blow your mind tomorrow. You ready? Get your seatbelts on.
Wait.
4x minus 6 equals 12.
So your homework tonight, I'm gonna give you some homework. If you would, look at your problems here. Let's circle some problems. I'm gonna give you a little dabble each type. I'll leave the fraction ones out of sight, out of mind. So since Adam did number 1, he already started. I'm gonna let you guys do number 1. Circle number 1.
Which one, the distributive?
Adam.
We're on the distributive side. Yes, just the one that says distributive. It should be the, your holes are on the left-hand side. It should say distributive property at the top. Everyone on with me? So the first one is 3 times the quantity C plus 5 equals 12. Okay, on the right side?
Yes.
Okay. So number 1, let's do. All right, number 3, Adam says this 3 is okay. And 4. Okay, so those 3. Out of those 3, I want you to check. Ready? Number 3. Put a star next to number 3. Like put check or do something. Okay? Number 1 and 4, if you get it wrong, guess what I'm going to make you go do?
Check.
Check it, redo it, and go back. Okay? So if you want to check them all, do that. All right, turn it over. Let's do
Lettuce.
number 3. Number 4. Seven. That's what Adam said. Heard him. No.
Adam, you should have just said 0, because then we wouldn't have to done
No, I pointed which one. You got to choose. Okay, so you got 3 problems on each side. On the combined side, I want you to check number 4. So put a check on that one. If you want to check them all, there's only 6 problems. I would assume that most of you could check them all. Make sure you're right. Okay, I would. That's what I would do. And then tomorrow we'll probably obviously finish our note sheet and then move on to fraction distributing and the opposite sign.